Okay, so this is the fourth and hopefully the last video for today. If I can get it to stay up, there we go. All right, and we got cut out when I was explaining these ones here. All right, so the fifth law, we've got log base a of 1 equals 0. That's because a to the power of 0 is always 1. Doesn't matter what a is. And in this case, a to the power of 1 is always going to get you a. So log base a of 1 is always 0 regardless of what a is. And log base a of itself equals 1 always as well. So let's do some examples. We're going to simplify log base 10 of x minus 3 log base 10 of x plus 1. First thing I want to do is I've got this constant out the front, and that makes it difficult for me to know what, I can't collect these together while I've got a 3 out the front. So I'm going to go to my third log law, and of course these work both ways. So if I've got a constant out the front, I can bring that up there to be the power of the argument. So my first line, I'm going to keep the log base 10 of x, and it's going to be minus log base 10 of x plus 1 to the power of 3. So that 3 has moved up to the power. Now I've got log base 10 of something minus log base 10 of something. So using my second law, I'm going to collect those together to be m over n. So this is going to be log base 10 of x over x plus 3 cubed. And that's me done. Okay, my second example is log base 5 of 81 over log base 5 of 3. So this one we're going to try and evaluate because we've got only numbers, no expressions. So the first thing I want to do is simplify this 81 here. So log base 5 of 81, I'm going to think about the fact that 81 can be written as a base raised to a power. 81 can be rewritten as 3 to the power of 4. And I'm going to keep my log base 5 of 3. And in my next line, this power of 4 is going to come down and be the constant using my third log law. The power comes out the front as a constant. So I get 4 log base 5 of 3 over log base 5 of 3. Now log base 5 of 3 is a number. I don't know what it is. And log base 5 of 3 on the bottom is the same number. So I can cancel those out and I get 1 and 1. So 4 times 1 over 1 just gives me 4. And that's me done for that one. Okay. Example 3. Move it down so you can see it. There we go. No, a bit further. Okay. Example 3, I'm going to solve for x. So I need to rearrange this equation to make x the subject. So what I can do here is I can use the fact that a logarithm is the inverse of a power, or I can just use the rewriting thinking. So if I think about what this means, it means that 10 to the power of 4 equals x. So I'm going to write it in that way. 10 to the power of 4 equals x. And then I just evaluate 10 to the power of 4. So I get x equals 10,000. I'm going to do something similar in the next one. I need to evaluate log base 2 of 3x plus 1 equals 4. So this tells me that 2 to the power of 4 equals 3x plus 1. So I'm going to write that 3x plus 1 equals 2 to the power of 4. Now the other way that I can think about this is because my base is 2, it's like going base 2 on the left-hand side. I raise everything to a base 2, and I do the same thing on the right-hand side. So both the left-hand and the right-hand side of the equations have become the powers, both to a base 2. But on the left-hand side, 2 to the power of log base 2 cancels itself out, and I get 3x plus 1, and I still have 2 to the power of 4 on the right. So I've got the same working, just a different way of thinking about it. All right, now I just need to solve. So 2 to the power of 4 is 16. So 3x plus 1 equals 16, gives me 3x equals 15, x equals 5, and I'm done. Now if I put that 5 back into the equation, I get log base 2 of 15 plus 1, which is log base 2 of 16, equals 4. And that's true. 2 to the power of 4 will give me 16. All right, my last one, I need to solve this one for x, and I'm going to use my log laws to help me do it. Because what I can't do is rewrite an equation where the logarithm parts are separated by addition or subtraction or division or anything, right? As long as they're separated by some kind of operation, it has to be the whole of one side of the equation is in the logarithm. So on the left, I've got a subtraction in the middle, so I'm going to go back to my second log law, which tells me that if I've got a subtraction, then the two arguments are going to be divided. So I'm going to rewrite this as log, and they're both base 2, of x plus 3 over x minus 2, and it's still going to equal, I haven't done anything to the right-hand side, it's still going to equal 3. Sorry, I just realised you can't see that. There you go. Okay. Log base 2 of x plus 3 over x minus 2 equals 3. And I've divided because of this subtraction in the middle. And now I can do my rewriting. So if I think of raising this both sides to the power of to a base 2, I get 2 to the power of log base 2 of x plus 3 over x minus 2 equals 2 to the power of 3. And then on the left-hand side, 2 to the power of log base 2 will cancel. X plus 3 over x minus 2 equals 2 cubed is 8. And now I've got just a standard equation that I know how to solve. I can multiply both sides by this denominator. X plus 3 equals 8 times x minus 2. I get x plus 3 equals 8x minus 16. So I've got, on this side, I've got 19 equals 7x, x equals 19 over 7, and I'm done. Okay. Now, I have to be careful here, and there is something I didn't mention to you guys earlier, and that is, I skipped over this and I didn't mean to, that the argument in my logarithm must always be positive, and I'll go into more detail about why that is tomorrow. But if I've got log base a of b, then b is greater than 0. This b comes from up here, this b up here. So if I've got log base a of b, then b must always be positive. So when I go back to this question, what I need to check is that this answer satisfies x plus 3 is positive. That comes from the first argument in the logarithm. And x minus 2 is positive, which comes from the second argument in the logarithm. And in this case, that's true. 19 over 7 added to 3 is positive, and 19 over 7 is more than 2. So if I subtract 2, I'm still positive. So this is fine. And that's it. All right, let me know tomorrow how you found this, and I'll speak to you soon. Bye.